Good morning. I am Love Jaiswal. Today I am going to explain the topic memory management thrashing concept. So let's start. Memory management is one of the most important function of an operating system because it manages the allocation and delocation of a memory among the different processes. One of the major problem in management is thrashing. Thrashing occurs when the operating system spends most of its time transferring pages between main memory and secondary storage instead of executing actual processes. So, lecture agenda. This presentation is divided into four major sections. First, fundamental. Second, causes and cause. Third, detection and controls. Fourth, prevention method. So, one by one, we will discuss every topic. First, fundamental. In this section, we will understand the basics of virtual memory, paging, and demand paging. In second, we will study the reason behind the thrashing and discuss methods to reduce its impact. Third, detection and control. We will learn how operating system identify whether the system is suffering from thrashing. Fourth, prevention methodology. Finally, we will discuss techniques used by modern operating system to prevent thrashing. So now next slide. Demand paging and foundation. Thrashing is directly related to the concept of demand paging because demand paging is a memory management technique in which pages are loaded into RAM only when they are required by the CPU. Like example, consider a program that consists of 100 pages. At a particular moment, the program may only needs pages number 1 to 10. So instead of loading all the pages, all 100 pages into memory, the operating system loads only those pages that are currently required. Like if you required only 1 to 10 pages, so operating system shares you only 1 to 10 pages. If you require more, then there is shares more than 10 pages. This approach provides several advantages, like reduce memory use, allow more program to run simultaneously, improves overall memory utilization, and etc. However, if a required page is not available in a RAM, so the CPU generates a page fault. Since hard disk and SSDs are much slower than RAM, frequently page frequent, frequent page faults can severely reduce performance. When page faults become excessively, then thrashing begins. Next slide. What is thrashing? So, if we will discuss about the thrashing. So, thrashing is a condition in which the operating system spends more time swapping pages in and out of memory than, than executing actual instruction. If we talk about the thrashing in a simple words, so the system becomes a busy in memory management activities instead of useful computation. So the thrashing is begins. Means अगर बोला जाए तो अगर जो सिस्टम है वो मेमोरी मैनेजमेंट एक्टिविटीज़ की जगह दूसरे काम में बिजी है कंप्यूटेशन वर्क में तो इस कारण से थ्रेशिंग होती है। एक एग्जांपल ले सकते हैं अपन सपोज द प्रोजेक्ट नीड्स 4 पेजेस A B C and D but available RAM can hold only 2 pages at a time. If initially memory contains a and B page, page A and page B, So if when page C is required, so if we already have two pages, page A and page B. So page A is removed and page C is loaded. Now memory contains page B and page C. So in next, if page A is needed again, so again same process is begin. Page B is removed, page A is loaded. So now the memory has the pages page C and page A. Page B is removed. So this cycle continues repeatedly. So as a result, the disk remains continuously busy, and CPU waits for pages. Process execution becomes extremely slow. So this situation is known as thrashing. Multiprogramming and CPU utilization curve. The graph shows the relationship between degree of multiprogramming and CPU utilization. Initially, increasing the number of processes improves CPU utilization because while one process waits for an input-output operation, another process can use the CPU. Therefore, CPU utilization increases steadily. However, after a certain point, the available memory becomes insufficient for all active processes. Each process receives fewer memory frames than required. Mm, Root case of thrashing. So there are two major reasons of thrashing. First, blind CPU scheduler, and second, locality defeat. The blind CPU scheduler. Modern scheduler tracks CPU core utilization metrics to regulate work. If utilization drops, the system blindly assumes it must spin up more tasks. So adding new processor further subdivided the scarce remaining physical memory frames, accelerating page faults and creating self-reinforcing death loop. In second, locality repeat. Programs usually access a group of related pages repeatedly. This group of pages is called locality. Example like a loop, function, array, recursive calls, etc. If the process does not receive enough frames to store its locality, so pages are repeatedly removed and loaded back into memory. So this result is staging. Next, locality of reference. Most programs follow the principle of locality. This means programs tend to access a small portion of memory repeatedly over a short period of time. So there are two important types of locality: temporary locality and spatial locality. So in first, temporary locality. Temporary locality means if a memory location is exists now, it is likely to be exist again in the near future. So इसके एग्जांपल अगर अपन ले लें तो लूप वेरिएबल, काउंटर्स, frequently used functions and many more. In second, spatial locality. So spatial locality means that if one memory location is exist, nearby memory location are likely to be exist soon. वो भी थोड़े टाइम के बाद एक्सेस हो जाते हैं. तो इसके भी एग्जांपल में हो जाएंगे अरे, सीक्वेंशियल इंस्ट्रक्शन, consecutive recording in memory, and many more. So chasing occurs when the operating system cannot keep these frequently used pages in array. Okay, next slide. Method of detection. So operating system use different method of detection tracing. Like PPF monitoring means page fault frequently method. Second, work working set analysis, and third, hardware utilization. So in the first PFF monitoring, the operating system continuously monitoring pages faults. If the page fault rate exceeds a predefined threshold, so the system assumes thrashing is occurring. Working set analysis. The operating system calculates the number of currently required by each processor. If the total memory demands exceed available frames, thrashing is detected. In last, in the last, hardware utilization. Thrashing produces several symptoms like CPU utilization decreases, swap area activity becomes very high, and response in time increases. So these symptoms indicates the presence of thrashing. The working set model. The working set model was introduced to solve the thrashing problem. The working set of processes is defined as the set of pages activities used by the process during a recent period of execution. The operating system calculates the working set size for every process. The formula is D equal to summation of WS S of I, uh, where D equal to total memory demand, WSS is working set size of each process. You know. If D if D is less than or equal to M, then the system works normally. And if D is greater than small m, so where m is difference available physical frames, so thrashing occurs. The operating system then suspends some processes to reduce memory demands. Detects, detection methodologies. You know, evalu- evaluation parameters, working set models, page fault frequency. If we will discuss about the evaluation basics, uh, both methods have their own advantage and disadvantage. If we discuss about the working set method, so advantages are that ki, first highly accurate. So because working set method is highly accurate, second point based on actual memory requirement, तो ये एक्चुअली मेमोरी रिक्वायरमेंट पे काम करता है. थर्ड, इफेक्टिवली प्रिवेंट्स थ्रेसिंग. ये इफेक्टिवली थ्रेसिंग से प्रिवेंट करता है. एंड डिसएडवांटेज आर डेट की बिकॉज मोर कैलकुलेशंस, ये कैलकुलेशन बहुत ज़्यादा प्रोवाइड करता है. हाई इम्प्लीमेंटेशन कॉस्ट, इसकी कॉस्ट भी बहुत ज़्यादा होती है. अब if now we will discover the page fault frequency method. The advantage of page fault frequency method is simply implementation. ये simply implement हो जाता है. Second, lower overhead required. Evaluation only on actual page fault in interrupt events. Okay. Third, fast decision making. ये बहुत ही फास्ट डिसीजन मेकिंग कर लेता है और प्रोसेस आगे हो जाता है. डिसएडवांटेज, इसका एक डिसएडवांटेज भी है. डिसएडवांटेज इज डेट लेस एक्यूरेट देन वर्किंग सेट मॉडल. ये वर्किंग सेट मॉडल से लेस एक्यूरेट होता है. तो इस नाउ वी विल डिस्कस द प्रिवेंशन मेथडोलॉजी. So this is our last topic, last point, prevention methodology. How to prevent from the thrashing. So these are several techniques to prevent thrashing. First, local replacement algorithm. Second, medium term scheduling. और थर्ड, इंक्रीजिंग फिजिकल मेमोरी। तो ये जो तीन टेक्निक्स है जिससे हम प्रिवेंट से कर सकते हैं थ्रेसिंग से। हाँ, तो दी फर्स्ट, लोकल रिप्लेसमेंट एल्गोरिथम। In this method, a process can replace only its one page. This prevents one process from stealing frames from another process. This second, medium-term scheduling. The operating system temporarily removes some processes from memory. So this process is called swapping memory. Swapping memory. When memory becomes available, the suspended process is brought back into memory. Last one, increasing physical memory. Adding more RAM increases the number of available frames. As a result, page faults decreases, CPU utilization improves, thrashing is reduced. So this is one of the most effective practical solution. So this is now the PPT is over. If we conclude the whole PPT, so the points are that thrashing is a serious problem in virtual memory system. Okay, so it also occurs because of excessive पेज फॉल्ट्स। अगर अपन ज़्यादा पेज एक बार में लाने की कोशिश करते हैं तो वो पेज फॉल्ट होता है और इससे थ्रेसिंग होता है। और one more point is that CPU utilization decreases while disk activity increases। अगर डिस्क की एक्टिविटी इंक्रीज होती है तो CPU यूटिलाइजेशन डिक्रीज हो जाता है। वर्किंग सेट मॉडल एंड पेज फॉल्ट frequently are commonly used for a डिटेक्शन। तो वर्किंग सेट मॉडल जो है वो पेज फॉल्ट फ्रीक्वेंसी के लिए ज़्यादातर यूज किया जाता है, वो अच्छे से डिटेक्ट कर लेता है। एंड लोकल रिप्लेसमेंट, मीडियम टर्म शेड्यूलिंग एंड इंक्रीजिंग रैम हेल्प प्रिवेंट्स थ्रेसिंग। ये चीज़ें हैं जो थ्रेसिंग से प्रिवेंट करती हैं। Therefore, proper memory allocation and process scheduling are essential for maintaining good system performance. ओके, तो इसलिए प्रॉपर मेमोरी एलोकेशन एंड प्रोसेस शेड्यूलिंग आर इसेंशियल फॉर मेंटेनिंग। ये बहुत ज़्यादा ज़रूरी होती है मेंटेन करने के लिए। ओके, सो थैंक यू।